Hello class, this is for your STL post lab. If you are not here, obviously it will be very difficult for you to do this. Still, I'd like you to watch it, think about how to do these types of things, and we will arrange a time for anyone who is absent to make it up. It will mandatorily be have to be after school. So objectives are to how to find the specific heat with calorimetry, and how to find percent error, and explain how does this all work. So this is how your post lab looks, but you should in some place, maybe on this page or on a different page, have your data table, which does not have to, but it may look like this, where you have, this is your cool water, your metal, and then for each one you want to find the mass, the initial temperature, and the final temperature. I noticed for some students it was definitely helpful to include all of their variables, including delta T, specific heat capacity, and heat. It was, however, not necessary. You had to take these in your lab. So I'm going to make up some random numbers. If you did the lab, use your numbers. If you didn't, now you might want to copy these down so you have an idea of how it might go. These are relatively realistic, but I am just simplifying it. Alright, so you should have these numbers with you, and then you can start by figuring out what the others. So the change in temperature, it's always the final minus the initial, so 26 minus 27, or excuse me, 26 minus 22 would give me 4 degrees Celsius of change. 26 minus 100 would give me negative 74 degrees Celsius. The heat capacity of water is 4.18, and that's just a known value that was on the board. And we're not sure about the heat capacity of metal or the heat of either the water or the metal. So to answer this question, to find the specific heat of your metal, this would be this box. This would be the last thing you do. You first have to find the heat, because we know that if they're in a closed system, essentially where this is your water and this is your metal, your heat is going to transfer from your hot metal to your water, and the amount the metal, this number is going to be the same. So the heat lost by the metal is going to be the same amount as the heat gained by the water, except since the metal lost it, it's going to be the negative version of. So I can say that my QW is equal to my QM, except it's negative because it lost. So I can then set up my equation one of two ways. You can just find the Q, or you can just put the equations equal to each other. I like to separate it out so you can see what's happening, but either would have worked. So when you're doing this, you can say that the QW is equal to MC delta T. So M is 100 grams, C is 4.18, and then delta T was 4 degrees Celsius. This is a straight multiplication problem. And this will give you 1,672 joules for your heat. 72 joules. And then since it's the same for the metal, except it's just negative because it lost heat, So you can set up a similar equation. I'm going to go a little below because I'm running out of room. So negative 72 joules. This is our. So now we're doing our metal. And then we do the mass, 500 grams, times the C, which we don't know, times the change in temperature, which was quite a large amount. You would divide by both of these. You can multiply them first. It doesn't really matter what order you do it in. So it crosses out, and that means we'll do it on this side as well, which will be 0.452 joules per grams degrees Celsius. Alright, so this is my specific heat of the metal. Alright, so then the next question is, based on your calculations, what type of metal do you think you were using? And does this make any sense? So I'm about to clear it. 0.452. So we want to figure out what type of metal we're using. So in this case, what you want to do is use on the other side of your paper, there is this table. Now notice that this table is in kilograms. Our answer is in grams. So if we want to talk about this as grams, divide each one of these by 1,000, or essentially move your decimal over 3 places, which makes them all decimals, which now looks a lot more similar. So it says, based on your calculations, what type of metal do you think we're using? So obviously I had fictitious numbers, but based on my fictitious numbers, you can look, it looks like it could either have been iron or steel, because they are very, very close. One reason they are very, very close is steel has iron in it. In fact, steel is mostly iron. Steel, I believe, for the most part, is iron and carbon. So that makes sense. They're very similar. So I could say, well, you know what, I think that it was steel, because one, it was the closest, and it was silver in color, which, if you've seen a lot of steel things, like stainless steel, you know, okay, well it's mostly silverish. And whereas if you have a cast iron pan, it tends to be pretty dark and red and maybe a little rusty. So I think that it was steel. Alright, and then what is your percent error? So your percent error is your theoretical, so what should you have gotten, minus what you actually got. So this is your number, essentially, over the theoretical again. And then since it's a percent, you're going to times it by 100 to get your percent. So for this one, this is my actual, where my theoretical would be, this is what, if it really was steel, this is what it should have been. So the math for that would be 0.54, or 0.45, excuse me, 0 minus 0.452 over 0.450 times 100. Plug that into a calculator. Alright, and I would get negative 0.44%. And that's actually really, really good. But not actually, because they were fake numbers. But if this was a real experiment, that's actually a very, very low percent error. So that's pretty good. The lower, for this, the lower the better. You want this to be as close to 0 as possible, because that's how far away you are. Alright, and the last question is, what are 2 ways in which you could have improved this experiment if given more time? So if you had lots of time, if you could maybe, so what are some things that will make your results more accurate? Think about maybe, this one I actually want to see what you get, so I'm not going to give too many hints. Think about how you can make it better. Alright, hopefully this video was helpful. Again, if you are absent, I will be arranging a time you guys can come after school to make it up. And I will see you guys tomorrow. On that note, tomorrow, second period, you are in the library. Everyone else, you're in G108. Make sure you bring your research packet. Make sure you bring your research packet. Remember, 5 are due by the end of the day. 5 C notes by the end of the day on Friday. Since you'll have time in the library to do that. Alright, see you guys tomorrow.